So in example 2, we want to figure out this quadrilateral as a parallelogram. Well, to be a parallelogram, we're going to have opposite sides that are parallel to one another. So if I can show that we have opposite sides parallel to one another, we have ourselves a parallelogram. Okay, what that means then is to be parallel, I'm going to go through and calculate the slopes and then see if the slopes are the same for opposite sides. So let's go look and find the slope for EH. Go up and over. So I go up 1, 2, 3, 4, over 1, 2, 3. And for EH, I got a slope of 4/3. If this is going to be truly parallel to FG, then I should also get a slope of 4/3. Go calculate the slope. Going over and up, I went over 3, I went up 4, rise over run it, boom, I've got parallel lines. I repeat that for the other one. I gotta have 2 pairs of parallel lines, so for EF, okay? Calculate its slope. I went over 1, 2, 3, 4, I went down 1, 2, 3, and rise over run, I get negative 4/3. All right, do the same thing for HG, and when you do that, you get a negative 4/3 again. So what we can say then is, yes, it's a parallelogram since we have 2 pairs of parallel sides. Okay? Now, to make it a rectangle, we want to go even further. We got ourselves a parallelogram, but in order to be a rectangle, we want to see if those adjacent sides are perpendicular to one another. So are the slopes what we call negative reciprocals? Okay, so as I'm looking at that, I just realized I was not paying attention very well. On EF, I have that as reversed. Okay, what I mean by reversed is the run was 4 and the rise was -3. And that is true for both of those. My bad on that. Because now when I do question 3, when I compare those adjacent slopes, okay, that EH slope that we got of 4/3 to the EF slope that we got of -3/4, we do have negative reciprocals. Okay, so since we have, and that's true for both of them, okay, since adjacent sides have negative reciprocal slopes, that means we have right angles. And a rectangle. So it's all about slopes and it's all about side lengths, and we're going to do a lot more work with that as we move on to the next page. Okay. So to make it a square, we need to then see if those sides are all the same length. So what that's going to be leading me into is the distance formula. Okay. We're going to use the distance formula here to figure out if we have the same lengths. Now the distance formula is going to be used as we have right there. You got to put it in your library. Okay, looks worse than it is. We're going to do some practice with calculating distances between 2 points on the coordinate grid system. All right, so let me go ahead and pause, upload.